Okay, welcome back. We're on page 249 talking about NAS. This is another one that's very similar. It's just the letters are turned around. Instead of NAS, it's SAN. Stands for Storage Area Network. And its concept kind of sort of looks the same. Okay, but here's how it works. These are separate things. Typically, you could get, traditionally they were run through a thing called, a fiber connection, an FC connection. Now that's not very common. Now, instead of having a fiber connect guy, you use just high-speed internet. High-speed Ethernet. So if you have like a 10 gig Ethernet cable, that you don't need a fiber connect card anymore. So, but the point here is, yes, it's storage, and the boxes look identical to a NAS. You couldn't look at a box and say, oh, that's NAS. Well, it could be. And in fact, in my case, and perhaps in all of them, you could designate half of your NAS box to run NAS and the other half as SAN. Now, let me explain the difference. In NAS, everybody can hit the NAS box directly. But in a SAN, the server is the only one that has the direct connection to the storage. And so it would be drive D or something, right? And so anyone who wants to get to drive D on the server is going to have to go through the server. So this is the wild, wild west. Everybody can hit this guy. This guy is not. Everyone can hit the server, and then the server responds. Okay, so storage area network is different than NAS, and maybe you could tell me the difference in a test question? Okay, you think you got this? Okay, so connected directly to the server. And anybody who wants to talk has to go through the server. Okay, so all the server has to do is just create a network share, right? We've done that before. You go to drive D and you say, I want to share this guy out, and everybody can see it. Okay. So fiber channel was the original idea, but that's rarely. Now you can get fiber channel over Ethernet, or even iSCSI over Ethernet. Okay, so now it's a difficult topic to talk about. To talk about the difference between block level and file level access. So this guy is what's called file access. It's an older protocol called SMB. We've talked about that. And so when the client asks for something, it asks for the entire file. It does not say, give me the first block of that data, the first 4,000K, and if I need more, I'll ask for the next 4K chunk. It doesn't do that. It only operates on a file level, which makes this guy not very suited for things like running a VM. Virtual machines really want to have, I want to give me just the first block in this thing. And so when I'm reading and writing blocks, I want to be very efficient. So it doesn't do that. SMB has been tweaked an awful lot to make up for the difference. But the real way to do it is what's called block-based storage. And so that's what this guy does. So when you plug a NAS in, you format the drive. You get a NAS folder or NAS drive on your server, and you format it in 4K, 4K box. And therefore, whenever you ask for something, it automatically comes up in 4K. So running, for example, a VM on the server would be using be using block-based. But if I was to run it the very same server over here, I'd be going through that NAS, the SAN to SMB block. So this would be using file. That would not. So one more time, I'd probably explain that poorly, but let me go through. For a NAS, everything has to be accessed to files and folders. You must read the entire file. You cannot say in this world here or in this world here. You can't say give me half the file. The machine doesn't know how to do that. On a SAN, I can go in there. I'm talking about application. I'm talking about you asking for block number 42 in a big file. That's not what I'm talking about. An application that can read a single block out of a file. So it's really cool if you had, let's just say you had a really big file, terabytes of data, and you only made one change to the guy. In a file base, I have to write the entire file out. All terabytes of it, just because I may change one byte. But in this system, where I have block based, I could say, well, the first half of the block is, great. So I don't have to write, 4 terabytes of file all at once. I'll just take that one block and go, doot. So it's a heck of a lot more efficient. It's just that its utility is somewhat diminished when you get there. Okay, so could you explain the difference between block and file and what the advantages and disadvantages are? Okay, one is ubiquitous, everyone can get to everything, but unfortunately you have to read the whole file, not just part of a file. Okay, and the other is very specialized and it's useful only to the server. It can't be used outside the server, where you read and write to a single block to make things a little more efficient. Okay, 251, talking about adapters and controllers. Modern motherboards have a host bus adapter component. It used to be a discrete card, a chip on the motherboard. No longer. It's just all just part of the chipset on your guy. So let's talk about serial bus technologies. Parallel seems like it'd be faster, right? It would make sense if I had to choose between a parallel interface and a serial interface. Serial would have to be punching a bunch, like 8, let's say 16 lanes or 16 bits. But a parallel could do it 16 bits in a single strike. So why don't we use parallel anymore? Well, the problem is what's called skew. The signal coming across, it's more timing dependent. In serial, I can just wait for something to show up and I respond, and I only have one thing to deal with. In parallel, you had to have 16 things waiting, and you had to deal with all 16 of them all at once. So it became so that you could not run parallel faster because it just consumed too many resources to be able to do that thing. So serial became the default standard for everything. We don't have like parallel printers anymore, right? We have SCSI printer. Well, we used to have SCSI printers. USB printer is a very common thing, and then a network printer is very common. Anyway, it's called skew. And the serial becomes more scalable. If I just speed things up, I can use the same interface and just tweak it a little bit. So let's talk about storage protocols. We talked about SCSI one more time, specifically for block level scenarios. That's what you would use SCSI for. iSCSI is iSCSI over TCP/IP. I could have it remote, kind of cool. Fiber channel is kind of sort of like SCSI, but for longer distance cables. And again, nobody really uses. Well, that's not true. If you're in a server farm, fiber channel cards are still available, and you get a fiber channel card on the server, an identical fiber channel card on the SAN box, and these guys you could spend. I'm not kidding. You can spend like $10,000 on one of these guys that runs at 100 megabit or something, or 1,000 megabit. And then fiber channel over Ethernet. That's the most common thing. You don't have fiber channel, you just run it over Ethernet. File sharing protocols. This is kind of what we talked about before about the difference between block and file, page 252. So server message block, SMB, that's the one that everyone uses. Microsoft attempted to rename it. They do crazy things. They called it the Common Internet File System, CIFS. That didn't last very long. So sorry, no one uses the CIFS standard. Everybody just uses storage message block. So SMB is great for. So for example, my NAS box runs Linux behind the scenes. Not that you could tell. And behind the scenes, it uses a file format that Windows doesn't know anything at all about. So all it does is translate between its file system, which is probably an ext4 file system. All it knows is SMB, and as long as it can understand SMB, no one else needs to know what's going on behind the scenes, because SMB file level protocol, doesn't matter what the actual physical file disk formatting technique is at the other end. So NTFS came from the Unix Linux days, network file system. That some people, if you have a Linux box, instead of using SMB, you'd probably want to use the native. All Linux boxes understand SMB, but you might want to use the native stuff because it goes a little better with it. File transfer protocol is typically a web kind of thing. You don't use it in NAS or SAN scenarios, but you could use it for copying files from one machine to another. I do that. For example, I have multiple NAS boxes, and so I want to synchronize the NAS boxes. I could just set one up to say, okay, transfer this to here, and then I go watch TV. So it's really for copying to and from, but not for file sharing. It's not. That's what its purpose is. And everyone knows about HTTP. And so yeah, you can use that for copying files, but that's clearly not its main purpose. Its main purpose obviously is to provide a graphical web interface. Secure shell is another cool thing. Basically, it's better than FTP because it has all the encryption and third factor authentication, all that stuff all built in. And again, it can do copying, but typically you don't use secure shell to share things. Okay, so there's a cool thing. There's a thing called HBA, and it's used with fiber channel switches. It's an interface standard that the fiber channel cards use. It's basically, you would have a type of switch, a fiber switch called SBA. HBA. Okay, so iSCSI. Remember that SCSI is block-based by nature, and iSCSI is SCSI over the internet, or over TCP/IP. So to make this thing work, you have to have a device called an initiator, and the initiator client fires up and looks for the target disks, and you could subdivide these disks into logical unit numbers. Like, that's just a SCSI thing. So I have a disk, but it's like partitions on the disks. So I can have a single disk in there, but have like several subdivisions of this thing. So if I have 128 terabyte SAN, I can use LUNs, logical unit numbers, to break those things up into anything I want. I could do, 4 of them at 32 terabyte a piece or whatever. It doesn't really matter. It doesn't have to be symmetrical. And the beauty of the SAN is I can share disks between servers. In other words, I can have, instead of having this guy pointing here, I could have this guy also pointing to the same storage box. And yes, the setup is such that if you were even to, this server was writing to a file and that server was writing to the exact same file, it can handle it. It can actually do the blocking thing and make sure that the files don't get corrupted. So this is a cool way of doing things. In a lot of disaster scenarios, you have multiple servers but a single storage box, and then you have another storage box someplace else, but all your servers can talk to one of those guys, and then maybe the other guys are replicated. Storage Spaces Direct, S2D. Basically what this means, this is kind of a Windows thing, is if I have a bunch of disks, I can just kind of group the disk into pools. This is called software-defined storage. Software-defined storage, where I just get a pool of disks and I subdivide them the way I want. Data duplication, or deduplication. Remember the story about my NAS box, or perhaps even in the SAN world? Wouldn't it be kind of cool that if I wrote the exact same file in 4 different locations, that physically it would automatically be stored only in one, and the other 3 locations would be just like, sort of like a shortcut. It's called deduplication. It just reduces the footprint down on your device by not including duplicate files. They show up in the directory structure and all that, but I'm using a Linux term. They're a hard link back to one location. Kind of cool. So let's say I copied a bunch of ISO files, and I don't know, I got 4 or 5 of them out there for some reason, but it's the exact same file. Well then, yeah, it would, each one of those things take up 7 gig. And so if I have 10 of them out there, that's a lot. So maybe dedupe is kind of cool for me. So dedupe is available in SAN and NAS scenarios. It's not technically available in the standard Windows suite, although we are going to install an add-on to the standard Windows suite, which will allow us to do those kinds of things. So storage tiering. So what happens if you have a slow device and a fast device? You might want to have the fast device like providing some of a cache. So for example, my NAS box has 6 standard, SATA drives. Well, they're not standard; they're red drives. But it also has a small amount of SSD built into it. So when I write something, it goes through the fast one first, and then the fast one kind of spills out into the slow. That's called storage tiering. We're coming up on the 15-minute mark. You guys know how this works.